So the next question, the IUPAC name of the following molecule. So first we have to do the IUPAC nomenclature. We have to assign the number of these carbons. So how the numbering will be done? Here the functional group is the double bond, that is an alkene. So we should give priority to this. So the numbering will either be in this way: 1 2 3 4 5 6 7, or maybe in opposite direction, that means 1 2 3 4 5 6 7. Now in first case the substituent are here, 4 substituent are there. One is propyl, normal propyl, and the second one is ethyl, and third one is 2-methyl group. So the substituent in the previous numbering system will appear at 1 2 4 4 in this position. On the other hand, in the second numbering system the substituent will appear at 1 2 6 6. So now as the 4 is the smaller than 6, so the previous numbering, that is the first one, will be the actual numbering, correct numbering. So now the substituent are propyl, ethyl and methyl. If we arrange this substituent in alphabetical order, then ethyl will come first, and then the methyl will come, and last the propyl will come. So ethyl is in 2 positions, so the nomenclature will be 2-ethyl, 2-ethyl, then methyl 4,4-dimethyl, 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 and the propyl is in 1 position, 1-propyl, 1-propyl. There are total 7 carbon in this ring, so this is an cycloheptane derivative. As this is an alkene, so it will be cycloheptene. So propyl cyclohept 1 in. So this is the nomenclature, this will be the nomenclature. The answer will be this. So the next question, the correct order of stability of the carbocation A to C is. So if we see the carbocations, this is an allylic carbocation, this is an alkylic carbocation, and this is vinylic carbocation. Now between these three, this carbocation has hybridization sp2, and the carbon has hybridization sp2, and this carbon have hybridization sp. Now sp hybridized carbon are much more electronegative than sp2 hybridized carbon. So positive charge on more electronegative atom is quite unstable. So this vinylic carbocation is unstable. This one is unstable. Now between these two, this is an alkylic and this is allylic. Allylic is resonance stabilized carbocation because it will have one resonating structure, and this is equivalent resonating structure. Actually for this carbocation, the positive charge is equally distributed between these two carbon center. So on the other hand, this carbocation is stabilized by the plus I effect of this ethyl group and 2 hyperconjugative structure for these 2 hydrogen. So as we know that resonance is a more stabilizing factor than the plus I inductive effect or hyperconjugative effect, and that's why the stability order will be C greater than B greater than A. Next question, the following carboxylic acid undergo decarboxylation upon heating. The use of decarboxylation is in the order. So the rate of decarboxylation will depend on the carbon ion generated by the removal of CO2. So from A, the carbon ion that will generate will be this. Let's say this is A prime. From B, the carbon ion generated will be this, and from C it will be this one. Now as this is B prime, this is C prime. Now as the negative charge is on sp2 orbital, so here resonance effect will not stabilize this carbon ion, so only the inductive effect will stabilize the carbon ion. Now in case of B prime, here nitrogen will have one lone pair of electron on nitrogen, so this electron pair and this electron pair which will quite repel each other, and that's why carbon ion generation at this position is quite unfavorable. So B prime here is least stable. Now between A prime and C prime, the C prime, in C prime the minus I effect of nitrogen is quite operate well, and that's why the negative charge will be quite stabilized by this nitrogen, and that is why the carbon ion C prime is quite more stable than A prime. So the stability order will be C prime greater than A prime greater than B prime, and that will be the order of decarboxylation. So the order of decarboxylation will be C greater than A greater than B, and that's why this type of question came in part C also. There was a question like this OME, and it was treated with n-butyl lithium and then ICH2, CH2I. The product will be, it is DOM, directed orthometallation. That means the n-butyl group will may take proton from ortho position of this group. That means the 2 proton may be taken, but it must be take only this proton. This proton will not be taken by n-butyl group, n-butyl base, because here the negative charge produced will be a repel with this lone pair of nitrogen. So here the negative charge will not produce, and that's why the product will be the 4-iodo derivative of this. So the product will be this. So guys, if you have any doubt regarding this video, please let me know in comment box.